Hello everyone. In this lesson, we are going to talk about redox reactions. Redox reactions. What are redox reactions? They are reactions in which reduction and oxidation happens simultaneously. But you need to first know what is oxidation and reduction. Okay. There are multiple definitions of oxidation. You can define oxidation in terms of electrons, in terms of oxygens, and in terms of hydrogens. Okay, you will be tested. You will be tested with the definition of electrons mostly, but it would help you if you also remembered its definition in terms of oxygen as well as hydrogen. Now, oxidation is loss of electrons. Oxidation is loss of electrons, loss of oxygen, and gain of hydrogen. Gain of hydrogen. Okay. And what is reduction? Reduction is gain of electrons. Gain of electrons. Gain of electrons. Gain of oxygen. In fact, it is loss of oxygen. Okay. I just one second. Let me just correct it. Okay, it's loss of electrons and gain of oxygen and loss of hydrogen. Okay, and reduction is gain of electrons, loss of oxygen, and gain of hydrogen. Okay, pardon me for that. Gain of hydrogen. Okay, they are going to test you mostly in terms of electrons. So you just need to remember that oxidation is loss of electrons and reduction is gain of electrons. You can remember it with an acronym we call oil rig. Oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Okay. Now you need to understand something, that when something loses electrons, let's draw a number line here. Let's draw a number line. Okay, there is 0 over here, 1, 2, 3, -1, -2, and -3. Now we know that when electrons are lost, positive ions are formed, and when electrons are gained, negative ions are formed. To be more precise, we can say that when electrons are lost, oxidation state increases. What is oxidation state? Oxidation state is actually the charge itself. The thing is, when you lose electrons, whatever is the oxidation state, it increases, in the sense it becomes more positive. And when you gain electrons, the oxidation state becomes more negative or less positive. For example, there is an element X which had a charge of -3. It gained one electron. Its charge will become -2. It means that we can say its oxidation state has reduced, or its oxidation state has increased, in the sense it has become more positive. Okay, so if something is going from, let's say, x -2 to x plus 2, you should know that it is oxidation. It is getting oxidized. It is changing from -2 to +2. It means it has lost 4 electrons. Okay, and when we say that something, let's say x plus 2 to x plus 1, something is going from x plus 2 to x plus 1, it means that its oxidation state is decreasing. It means that electrons are being gained, so it will be reduction. So we'll say this element is reducing. Okay, it's gaining electrons, and we'll say this element is the same element, in this case, is oxidizing. It is losing electrons. Okay, so if something changes from -2 to 0, that thing will be oxidizing. If something changes from 0 to -2, that thing will be reducing. If something changes from +1 to +2, that thing will be oxidizing. If something changes from I'm talking in terms of charges, by the way. If some element changes from +2 to +1, that element is reducing because its positive charge is just reduced. So remember that, okay? So oxidation is loss of electrons, reduction is gain of electrons. When we say that some element is getting oxidized, it means that that element is losing electrons, and when we say some element is getting reduced, it means that something is gaining electrons. Okay? Moving on. Let's write a redox reaction. Redox reaction is a reaction in which reduction and oxidation happens simultaneously. It is quite commonsensical to think that oxidation and reduction will always happen simultaneously. Why? Because if in a certain reaction electrons are being lost, then in that same reaction electrons have to be gained as well. Right? If electrons are being lost at one place, if one element is losing electrons, then another element has to gain those electrons to complete the cycle. Or if an element is gaining electrons, it means that electrons are lost from another element. So they are going to be reactions in which oxidation and reduction have to happen simultaneously. That is quite commonsensical if we just visualize the definitions in terms of electrons. Now let's write an equation. Let's write a redox equation. Magnesium react with H2SO4, or let's write it like this. Magnesium reacts with oxygen to form magnesium oxide. Now, if they ask you to balance this equation using half equations, you will have to write half equations for this. I think I should choose a bit easier equation so that you guys have no problem. This equation more suitable for A-level students. Okay, you don't need to balance redox equations. So magnesium reacts with H2SO4 to form magnesium sulfate and hydrogen. Okay, now and let's write down the charges. All the free elements have zero charge. Free elements means which are unattached, which exist alone. They have a zero oxidation state. They do not have any charge. Okay, charges are created when one element bond with another element. Okay, now hydrogen here has a +1 charge. We know that. Sulfate has a +2. Sulfate has a -2 charge. Ion. Okay, sulfate has a -2 charge. One hydrogen atom has a +1 charge. Two hydrogen atoms will have +2 charge. So +2 -2 0. Overall charge on H2SO4 is 0. Magnesium has a +2 charge. Sulfate has a -2 charge. Again, overall the charge is 0, but individually the charges exist. Now let's write the half equations. Now you can see magnesium is changing from 0 to +2. Magnesium is changing from 0 to +2. What does that mean? It means that magnesium is losing electrons, or we can say that magnesium is getting oxidized. Okay, check out sulfate. Sulfate is going from -2 to -2, so it is not nothing is happening to sulfate. What about hydrogen? Hydrogen is changing from +1 to 0 here. Okay, hydrogen is changing from +1 to 0 here. So there are one hydrogen ion, the two hydrogen ions. How would you write two hydrogen ions? You have to write it in the form of coefficient. Two hydrogen ions are turning into H2, right? Okay, now this is changing from +1 to 0, which means it is gaining electrons. Which means it is getting reduced. So this is going to be an oxidation equation, and this is going to be a reduction equation. Okay, they are overall called half equations. Okay, in which if we only mention one element. Okay, there's only a mention of only one element in each of the half equations. Now you need to balance their charges. You need to balance their atoms as well as charges. Atoms are already balanced. There is one atom of magnesium on the left, one atom of magnesium on the right. Okay, now we need to balance charges there. Okay, here the charge is 0 on the left, the charge is +2 on the right. Now how would I balance the charges here? I would balance the charge with the help of electrons. Now if I add 2 electrons over here, so 2 electrons will bring a -2 charge. So -2 + 2 will equal to 0. So the charges will be balanced. Okay. Similarly, in this case, charge on the left hand side is +2. One hydrogen ion has +1 charge, two hydrogen ions will have a +2 charge, and the charge on the right is 0. Okay, now do you have to balance these charges? So how can I make +2 equal to 0? Okay, I have to introduce 2 electrons over here. If I introduce 2 electrons, it will bring a -2 charge and will equal to 0. Okay, so many students ask what would happen if you add 2 electrons over here. If you add 2 electrons over here, on the right hand side the charge will become 0, -2, -2. So -2 is not equal to +2. So I have to add electrons over here. Okay. Now many students find it more convenient to just cram it. You can just remember it as well. If you don't want to balance the charges there, you can just remember that oxidation, whenever you're doing oxidation, whenever you're writing an equation for oxidation, electrons are always written on the right hand side, and whenever you're writing an equation for reduction, electrons are always written on the left hand side. So in short, oxidation is happening on the right hand side, reduction happens on the left hand side in terms of electrons. So if you're not comfortable with balancing charges and find it more convenient to cram it, that's on you. Okay, but I just explained you the basic concept that how do we add electrons on both sides. Okay, now let's do another equation. Okay, so the other equation is iron oxide is reacting with aluminium to form iron and aluminium oxide. Now the first thing you need to do is you need to write down their charges. So oxygen has a -2 charge. Now there are some times when you don't know the charge on, let's say you don't know the charge on an iron because it's a transition element. Its charges are different. Its charges change. So how would you write the charge over here? With the help of oxygen. Now we know that oxygen has a -2 charge, right? One atom of oxygen has a -2 charge. 3 will have -6 charge. 3 oxygen atoms will have an aggregate of -6 charge. So this charge has to become +6 for this compound to be neutral. We know that all the compounds are neutral. They have to be neutral. So the overall charge on oxygen is -6. Okay, and I want to make the charge of iron equal to +6. Now I'll have to keep the charge of iron +3, so that one atom of iron has +3 charge, two atoms will have +6 charge. We know that iron can have both +2 and +3 charges. Okay, so both iron and oxygen will have the magnitude of charge. Okay, will have equal magnitude of charge but opposite operations, as in plus and minus. Now aluminum is a free element, will have a 0 charge. Iron is a free element, has a 0 charge. Oxygen will have a -2 charge. We know aluminum has a +3 charge. So here again 3 2s are 6, -6. Oxygen has an aggregate of -6 charge and aluminum has an aggregate of +6 charge. Okay, now let's see which element is getting oxidized and which is getting reduced. Now iron is changing from +3 to 0. +3 to 0, it means it is gaining electrons. Oxidation state is reducing, it is gaining electrons, it means it is getting reduced. Okay, oxygen, nothing is happening to oxygen, it remains the same in terms of charges. But aluminum is changing from 0 to +3. Aluminum is changing from 0 to +3. It means its oxidation state is increasing, it is getting more positive, so it is losing electrons, or we can say it is getting oxidized. Aluminum is getting oxidized, iron is getting reduced. Okay, now let's write it down. So two iron ions are changing to two iron atoms. So 2 iron ions are changing to 2 iron atoms. 2 iron atoms. Okay, so how would that happen? Now for each iron ion to convert into each iron atom, okay, I will again use the same logic, use the same concept. Okay, I have to balance the charges over here. There is a +6 charge on the left hand side, and then there is a 0 charge on the right hand side. Okay, I'll have to make +6 equal to 0. Again, then I have to add 6 electrons over here. So that minus 6 comes here and the overall charge becomes, the charge on the left and the charge on the right becomes 0, equal to 0, both sides. Okay, this is what, this is reduction. Like I told you, reduction happens on the left hand side and oxidation happens on the right hand side. That's one way of cramming it. Okay, but it will really help you. Sometimes you don't, if you are not, if you're getting confused, okay, which happens on the left and which happens on the right, you can always resort to the actual concept, which is balancing charges on both sides. So iron is changing from +3 to 0. Now what is happening to aluminium? Two aluminium atoms are changing to two aluminium ions. Now let's write it down for aluminium. Two aluminium atoms are changing. Two aluminium atoms are changing to two aluminium ions. Okay. Now, okay, the charge on the left is 0, the charge on the right is +6. I'll have to make, either I can make 0 equal to +6, which I cannot because I only have electrons to play with. The electrons introduce negative charge. So if I add electrons over here, it will become -6, which is not equal to +6. So I'll have to introduce 6 electrons on the right hand side so that the charges are balanced. So this is oxidation that is happening on the right hand side. Okay, now both equations I've left midway. Okay, I've left both the equations midway for a particular reason. Obviously, I just wanted to tell you first that how do things work. Right now, let me just make some space. Here. Okay. There you go. Right. Now this is not, we have not still written the net redox equation. We will have to write the net redox equation now. The net redox equation, pretty much like net ionic equation. So you have written the oxidation equation, you have written the reduction equation. Now 2 electrons are being lost and 2 electrons are being gained. Now what would happen? You have to solve it simultaneously, like we solve simultaneous equations in maths. So these electrons will cancel each other out. So you are left with a net equation of magnesium reacting with 2 hydrogen ions, and it forms magnesium plus 2 ion and hydrogen gas. So that would be the net redox equation for this particular reaction. Okay, what about this one? You can write the net redox equation for these as well. 6 electrons cancel each other out. Okay, so you're left on the reactant side, you're left with 2 iron and 2 aluminium. On the product side, you're left with 2 iron atoms and 2 aluminium ions. So the beauty of a redox, of this net redox equation, is that it clearly tells you it only includes those elements which are either getting oxidized or getting reduced, and it tells you exactly which element is getting oxidized and which element is getting reduced. For example, iron is clearly changing from +3 to 0, so it is getting reduced, and aluminium is changing from 0 to +3, it is clearly getting oxidized. So that's the beauty of a redox, net redox equation. Okay, now you need to know some oxidizing and reducing agents. Okay, there are some famous oxidizing agents, and then there is only one reducing agent that is tested: oxidizing agent and reducing agents. Some famous oxidizing agents are potassium dichromate. One is potassium dichromate, and the other oxidizing agent is potassium manganate. I'll let you know what is oxidizing agent just in a minute. Potassium manganate. Again, what is the reducing agents? It's only one. You just need to remember that aqueous potassium iodide. Okay, now what are oxidizing agents? You need to first be familiar with the definition itself. Oxidizing agents are substances which oxidize others, but get reduced themselves and get reduced. They oxidize others and get reduced themselves and get reduced themselves. See, it's pretty simple. If something is oxidizing another thing, okay, if a substance is oxidizing another thing, okay, which means that if a substance is making another substance lose electrons, so obviously those electrons will have to be gained by the same substance. Okay, now what it's easier to define oxidizing agent with the fact that oxidizing agents gets reduced themselves. Now, if you just have to identify in this case, let's say in this case, I have to identify which one is the oxidizing agent, magnesium or hydrogen. Okay, how would I identify it? I would just see that which is getting reduced, which element is getting reduced. So hydrogen is getting reduced. So when hydrogen was getting reduced, which means hydrogen was gaining electrons, these electrons came from magnesium. So hydrogen actually oxidized magnesium in the sense that hydrogen gained electrons by making magnesium lose electrons first. So hydrogen is an oxidizing agent. An oxidizing agent is a substance which gets reduced itself but oxidize others. And how do you identify it? You identify it from an equation. You identify any element that is actually gaining electrons. Okay, that element has to be an oxidizing agent. Why? Because if it is gaining electrons, it means that it is getting reduced, and if it is gaining electrons, these electrons have to come from somewhere. Okay, and that means that it has oxidized another element to get reduced itself. Okay, so that's the concept behind oxidizing agents. Similarly, let's check here. Which one is the oxidizing agent? Iron will be oxidizing agent because it is getting reduced. It is gaining electrons by making aluminium lose its electrons. So it's oxidized magnesium and gets reduced itself. Okay, and what are reducing agents? The concept remains the same, you just have to flip the definition. Okay, reducing agents reduces others. Reducing agent reduces others but gets oxidized itself. But gets oxidized. What does that mean? It means that a reducing agent loses electrons, which isn't gained by another electron. So when a reducing agent is losing electrons, automatically it is getting oxidized. Now these electrons are going to be gained by some another thing. So that element will be getting reduced. Again, how do you identify a reducing agent over here? Reducing agent is one which gets oxidized itself. And which one is getting oxidized? Magnesium is getting oxidized itself. It is getting oxidized itself but reducing the other element. When a substance is losing electron, those electrons have to be gained by another element. So automatically, if a substance is getting oxidized, okay, then it will automatically reduce another element. Okay, so that is the concept behind reducing agents. Here reducing agent will be aluminium because it is getting oxidized, and then reducing iron because the electrons it lost goes to iron. Okay, so that's the concept for oxidizing and reducing agents. Now let's talk about tests for oxidizing agents and reducing agents. Testing. First, let's test for oxidizing agents. Test for oxidizing agents. And test for reducing agents. Test for reducing agents. Now, okay. You also need to know the color changes. Let me just tell you the color change. Now, oxidizing agent gets reduced, right? Oxidizing agent gets reduced. When they get reduced, they change colors. Potassium dichromate turns from orange to green. Okay, and potassium manganate turns from, I don't have pink color. Okay, let me see if I have pink color. Not really, not that pink color. Anyway, a potassium dichromate turns from orange to green, and potassium manganate, you must be already familiar with it. What is the color of potassium manganate? It turns from purple to colorless. Potassium manganate turns from purple to colorless. You should remember these color changes. Okay, and what is the color change of potassium iodide? The color change for potassium iodide is colorless to brown. Colorless to brown. So potassium dichromate is an oxidizing agent. When reduced, it changes from color from orange to green. Potassium manganate is another oxidizing agent. So when it is reduced, it changes color from purple to colorless. Aqueous potassium iodide is a reducing agent. So when it gets oxidized, it changes color from colorless to brown. Now let's talk, how would you test for oxidizing agent? For example, if I have a solution and I want to test if that solution has an oxidizing agent, what would you do? Now we know that oxidizing agents get reduced. So what would I do? I would add a reducing agent. Okay. I would add a reducing agent. If reducing agent gets oxidized, we know that reducing agent gets oxidized. If reducing agent gets oxidized, it means that there is an oxidizing agent here. There is an oxidizing agent here. Because oxidizing agent oxidize others, and reducing agent wants to get oxidized. Okay, so if you want to test for oxidizing agents, you'll have to add a reducing agent, and reducing agent will automatically be oxidized. Okay, and when it gets oxidized, it changes color. It changes color, it tells you that there is an oxidizing agent in the solution. And how would you test for reducing agents? You would test for reducing agents by adding, let's say I have to test for reducing agent. If there is a reducing agent here, now reducing agent gets oxidized. Okay, so what will I do? I will add an oxidizing agent. Now, since they both are going to interact with each other, oxidizing agent wants to get reduced, and reducing agent reduces others. And on the other hand, reducing agent wants to get oxidized, and oxidizing agent is doing what? Oxidizing agent is actually getting reduced. So how would I know if a solution has a reducing agent? This oxidizing agent that you are adding, let's say you are adding potassium manganate, it will change color, which it happens when it gets reduced, it will change color in case it is positive. Okay, if I add, let's say for test for a reducing agent, if I added potassium manganate, for example, okay, that potassium manganate would have gotten reduced, and its color would have changed from purple to colorless. So that's the basic concept about how you test for oxidizing agents and how you test for reducing agents. Okay, I hope you got the basic concepts of this chapter. It is a tad bit complicated. I mean, students find it difficult to grasp. So I'm going to do some past paper questions and hope that they are going to help you in grasping these concepts and applying these concepts. Okay, so question number 1. Which equation does not represent a redox reaction? Redox reactions are pretty easy to identify. If there is a free element, for example, let's say if there is oxygen over in one of these equations, so you can easily assume that this reaction can easily be a redox reaction. Why? Because oxygen on one side, if it is unattached, it is going to be attached on another side. So it will either have it is going to have some charge on the other side, which means that it will either be getting oxidized or reduced. Right? It will either be getting oxidized or reduced, and if either of that happens, if either oxidation happens or reduction happens of this free element, there's going to be the opposite of that as well. So it is going to be a redox reaction. So it is a bit easy to it gets a bit easy to predict if there is a free element in the reaction. For example, this reaction has a free element. We know that iodine has a zero charge here. It will automatically have a -1. If it is getting reduced, there will be some element which is getting oxidized as well. So it is a redox reaction. Okay. Let's take this example. This is also a redox reaction because it has free elements. Okay, and even B. can be a redox reaction, because O is going from 0 to -2 and sulfur must also be changing its state. Okay, now the answer would be A. It does not represent a redox reaction. Now moving on. Okay, a compound X is an oxidizing agent. X is bubbled through separate solutions of aqueous potassium iodide and aqueous potassium manganate. Right? X is an oxidizing agent. Potassium iodide is a reducing agent. Right? Potassium iodide wants to get oxidized, and this oxidizing agent wants to oxidize the other. So clearly there is going to be a color change. Potassium iodide will turn from colorless to brown. Okay, what will happen to this? Now potassium manganate is an oxidizing agent as well, and X is an oxidizing agent as well. So there will actually be no interaction between them. There may be physical interaction, but there is no chemical interaction between them. So there will be no change of color. So answer would be C. Okay, which equation describes the reduction process in this reaction? Reduction is gain of electrons, and gain of electrons, if we remember the cramming concept, that was that reduction happens on the left hand side. Okay, electrons are gained on the left hand side. Now this cannot be it. Electrons are gained on the right. Okay, this can be it. This cannot be it. Now you are left with two equations, iron and chlorine over here. Now which one will be reduction? You need to see that. Okay, let's check that. Here the charge on iron is +2. The charge on iron here is +3. Okay, so it is losing electrons. Okay, it is losing electron. Iron 2 is changing to iron 3. Iron 3 is not changing to iron 2. So this cannot be the equation as well. Answer would be B. Okay. So how is calcium ion formed from a calcium ion? It's pretty easy, by losing 2 electrons. Now let's do question number 5. Iodide ions, we know potassium iodide is a reducing agent. Iodide ions are readily dashed. A positive result of this test is when the solution changes from Y to Z. The solution changes from colorless to brown. So we have colorless to brown, two options, B and D. Now what is happening to iodide ions? See, potassium iodide is actually changing to iodine gas. That is why the color changes from colorless to brown. Okay, and it's changing from -1 to 0. So potassium iodide is what? It's a reducing agent, which means it is going to get oxidized itself, and iodine is the part which is getting oxidized. So the answer would be B. Okay. What is right ionic equation for a redox reaction? This is not a redox reaction. This is not a redox reaction. This is not a redox reaction. A redox reaction shows clearly which element is getting oxidized and which is getting reduced. Like in this, zinc is getting oxidized, copper is getting reduced. Answer would be D. Okay, how many of these reactions are redox reactions? Now this is the redox reaction. There are 3 elements. This is a redox reaction. This is a redox reaction. This is not. So 3 reactions are redox reactions. Okay. So construct an equation for this reaction that molybdenum can be manufactured by heating this oxide and aluminium. So you are heating the oxide with aluminium and you are forming molybdenum, and obviously the other one would be aluminium oxide, Al2O3. You'll have to balance it. 2 aluminiums, and it's already balanced now. Explain why this reaction involves both oxidation and reduction. Aluminium is changing from 0 to +3, okay, and molybdenum is changing from +6 to 0, because it's -2. Oxygen is 3 into 2, 3 into -2, -6. So it will be changed. It will have +6 charge. Okay, it is changing from +6 to 0. So you will write that aluminium is losing electrons. Aluminium is losing electrons. You can also write the oxidation state change from 0 to aluminium change from 0 to +3, and molybdenum is gaining electrons, whose oxidation state is changing from +6 to 0. Okay. Which step is reduction? Explain your answer. Reduction is gain of electrons. The gain of electrons you always write on the left hand side. you know the logic now behind it. Okay, so answer would be step 2. Step 2 is reduction. Explain your answer. Because electrons are gained. Because electrons are gained. Okay, which ion is the oxidizing agent? Oxidizing agent will be the ion which is getting reduced. So it will be silver ion. Silver ion, because it is getting reduced. Because it is getting reduced. Okay. Now you need to remember one thing. Now if you see this reaction, 2 electrons are being lost and 1 electron is being gained. That doesn't happen. That should not happen. Okay, so if they ask you to write a net equation for these type of half equations, remember that you'll have to make electrons equal to each other. The number of electrons lost must be equal to the number of electrons gained. So there are 2 electrons being lost, 1 electron being gained. I just have to let me write this equation first. Br2 plus 2 electrons, and if listen, I have to multiply this equation by 2. We'll have 2 Ag plus 1, 2 electrons forming 2 Ags. So these electrons will cancel each other out and you will be left with 2 Ag plus 2 Br forming Br2 plus 2 Ag. Okay, so that's how you write the net ionic equation for such reactions. You'll always have to check whether the electrons that are being lost are equal to the electrons being gained. Okay, and if they are not, you'll have to multiply by the suitable coefficient. Okay, so this is all from this chapter. I'll see you in another lesson. Okay, until then, take care. Allah Hafiz.